Now, topic is classification of circuit elements. We discuss already what is circuit element. Circuit elements are of two types. First, circuit elements. Those are simple circuit element and general circuit elements. So come to simple circuit element. Simple circuit elements examples are resistor, inductor, capacitor, voltage source and current source. Comes under simple circuit elements. When we can why we are calling those only as circuit elements? Why you are not calling some other any? Suppose you take textbook. Why you are not calling it as circuit element? And why those only are called circuit elements? Because circuit element is a two-terminal device which gives the mathematical relation between voltage and current. Circuit element is a two-terminal device which gives the mathematical relation between voltage and current. Suppose you take resistor example. What is Ohm's law across resistor? We discussed P is equal to I into R. Means in presence of resistor, the relation is existing between mathematical relation is existing between voltage and current. The mathematical relations are of two types that we know: directly proportionality or inversely proportionality. Whatever may be the element is existing, it is called a circuit elements. Simple circuit elements. Why? Because those are not further dividable. Those are called circuit elements. General circuit, simple circuit elements. General circuit elements means example transformer. So transformer combination of two simple circuit elements like resistor, inductor, generator. The combination of resistor and inductor. Coils will be placed. It means a combination of circuit elements. Simple circuit elements is called general circuit elements. The examples for general circuit elements are generator, induction motor, three phase or single phase. So any RL circuit and RLC circuit combination. Those are the examples for general circuit elements. Now come to circuit elements basic classification. Those are of four types. So 5 types: linear and non-linear elements, active and passive elements, unilateral or unidirectional, and bilateral or bidirectional device. Fourth classification: lumped and distributed elements. And fifth, time variant and time invariant elements. Time variant and time invariant elements. First, we'll see linear and non-linear elements. In electrical engineering, one linearity principle will be there here according to definition of circuit elements. If in the circuit elements the relation between voltage and current is directly proportional, the element which exists this linearity principle is called linear element. The element which doesn't obey this linearity principle, V is proportional to I, is called non-linear element. This V is proportional to I is also called superposition principle. Means with the element which exists Ohm's law, which is directly proportional to I. So the examples for linear elements here are resistor, inductor and capacitor. Why? Because if you see Ohm's law across resistor, V is equal to I into R. Means in presence of resistor, the relation between voltage and current is directly proportional. So resistor is the example for linear elements. Come to inductor. Mathematical Ohm's law across magnetic Ohm's law across inductor defines as V is equal to L into di by dt. Whatever may be the current, varying with respect to time or not varying. Means in presence of inductor, there also we can say the relation between voltage and current is directly proportional. Now come to voltage across capacitor. V is equal to 1 by C integral I dt. So in presence of capacitor, there also the relation between voltage and current is directly proportional. Hence we can say capacitor is also the example for linear elements. Come to non-linear elements. All sources will come under non-linear elements. All the sources will come under non-linear elements. Why? Because we discussed already sources, the characteristics we done between the voltage source and the current sources. Ideal, practical. There was the characteristics, the curve. Means sources we can't say directly whether it is a linear or non-linear element. By drawing characteristics only we can say the relation between voltage and current. If linear characteristics we can say linear, but for the sources we draw characteristics, everywhere we are getting non-linear characteristics. Hence we can say all the sources are the best example for non-linear elements. Now come to active and passive elements. Active, the elements which gives energy, which delivers energy to the other elements of the circuits, are the examples for active elements. Means all sources, voltage source, current sources are the examples for active elements. Come to passive elements, the elements which takes energy or power from other elements of a network. Those are the examples for passive elements. Examples: resistor, inductor, capacitor. Under steady state condition, inductor, capacitors are called passive elements. Now come to unilateral and bilateral elements. Unilaterality means the element which allows current in one direction, that element is called unidirectional or unilateral element. And the element which allows currents in the both directions, both the terminals of the direction, both the terminals, if you given anyways current, it will allow currents in the both directions of the element. Then we can say that is the example for bidirectional element. If you take voltage source, current always flows from positive terminal to negative if there is no external forces. That's why you can say all the sources are the best examples for unilateral element. Suppose take diode also. Current always flows from anode to cathode. So diode also will consider the best examples of unilateral element. Bilateral, bidirectional, resistor, inductor, capacitor. Those will allow currents in the both directions. So we can say those are the best. Resistor, inductor, capacitors are the best examples for bilateral elements. Next, lumped and distributed elements. Lumped means which has to visible to eye. If you see the circuit, if you are able to see the circuit physically, or if you are able to represent on the paper, means we can say there is a lumped circuit. In that, those every element is called a lumped element, means mostly it has to visible to eye. Physically, that element network has to exist or element has to exist. Very important. Lumped means. Distributed means the elements which is not visible to eye, means we can imagine, we can estimate. The best example for distributed element is God. We are assuming, but we are not seeing the God. That's why Kirchhoff's laws are not applicable for distributed elements we studied. Those are applicable for lumped, because physically element has to exist. Then only you can say, if KCL if you taken, if currents are entering, current leave, means you have to see the network with your eyes. That's why Kirchhoff's laws are applicable only for lumped circuit elements. Kirchhoff's laws are failed for distributed elements. So to analyze the distributed elements, we use Maxwell's equations. Maxwell's equations we use for distributed elements. So what is circuit elements? I was given definition. What is simple circuit example, general circuit example. Circuit elements what to discuss. It's a two-terminal device which gives the mathematical relation between voltage and current. The circuit element. Next, Kirchhoff's laws. What is the purpose of Kirchhoff's laws? We have to know first. The purpose of Kirchhoff's laws are to find current or voltage or power in any one particular branch of your network. In any one particular branch of a network, to find current, voltage, power, we use Kirchhoff's laws. And these Kirchhoff's laws are applicable for lumped circuit elements. Lumped means those are visible to eyes, eye, our eye, eye. Element has to exist, or we have to represent the network on the paper, on the board. So Kirchhoff's laws are applicable for lumped circuit elements. And these Kirchhoff's laws are of two types. Those are Kirchhoff's current law and Kirchhoff's voltage law. First, let me explain about what is Kirchhoff's current law. What is the definition for Kirchhoff's current law? The difference in a lumped electric circuit. In a lumped means visible circuit, the algebraic sum of branch currents leaving the junction at any one particular time t seconds is equal to 0. In a lumped electric circuit, the algebraic sum of branch currents leaving the junction or network at any one particular time is 0. Here we have to know what is junction or node. Electrically we can call node. Generally we can use the word junction. So we know that junction will exist where between at least between two roads or more than two roads junction will exist. Here we have to know first what is a node. Junction of more than two or more than two elements. If you know that if your two lines or three lines you are crossing, generally we are calling it as a junction, chaurasta. See now here, these nodes are of two types. Depends on number of elements are existing. Nodes are of two types. Those are simple node and principal node. Two types of nodes are there: simple node and principal node. Simple node will exist between two elements only, or two branches. Principal node will exist between more than three or at least three or more than three elements. So remember, now circuit element is nothing. We can now onwards we are using the word branch. Branch means it's a two terminal device. Branch means the branch existing means there must be some voltage has to exist, then only we can call it as a branch. If there is only resistor, where we can't call it as a branch. If current is flowing through the resistor, voltage will exist across the road, then only we can call it as a branch. Similarly, in ideal just voltage source only, isolated voltage source separately is there, we can call that also as a circuit element or branch. Why? Because voltage is existing between the two nodes, two terminals. Now come to KCL. What I said, algebraic sum of branch currents leaving the junction is 0. See here, one simple network we take an example. For this, I am going to giving explanation here. See here, the visible, it is visible physically. So how many nodes are you able to see? One node only we are going to see. How many elements are there at that node? 1, 2, 3, 4, 5 elements are there. Means we can call it as a node. So particular what type of node? It is a principal node. Now see here, I assumed there, so through some branches currents are flowing, through some branches currents are entering. What definition is given at any particular time? Why? Because at that time maybe 5 loads are connected at that node. Maybe after some time some loads may be disconnected. Loads are nothing but what? In our home, electrical appliances like fans, tube lights, mixie, washing machine, TV, all the electrical appliances will come under load. Which assume maybe at that time you are going to using 5 bands, so 5 loads are connected. After 1 hour somebody may switch off, so 4 loads. That's why any particular time only we apply KCL. Now according to definition of KCL, what you are saying, algebraic sum of branch currents leaving. So here leaving currents only I am going to considering. If any current is entering to the node is leaving current is nothing but we can represent with the negative sign. Thus see through R1 branch current is entering to the node is I1. Then what is leaving current? Minus I1. So minus I1, minus I2, minus I3 plus I4 plus I5 is equal to 0. With this we can write I1 plus I2 plus I3 is equal to I4 plus I5. With this definition we can say sum of the currents leaving the node is equal to sum of the currents entering the node. If anyone asks KCL definition means don't say as sum of currents entering equal to sum of current leavings. We have to use the word must in a lumped electric circuit. Algebraic sum branch currents leaving the junction or entering the junction is 0. With that only we can define sum of currents entering equal to sum of currents leaving. As you know, instantaneous value of current at a particular time you are saying I is equal to dq by dt. I is equal to dq by dt. Means any one particular time we are going to apply KCL means all the times T1, T2, T3, T4, T5 each branch time is same. So if you apply here, if you return the time value here, I can get as I dq1 by dt1 plus dq2 by dt2 plus dq3 by dt3 is equal to dq4 by dt4 plus dq5 by dt5, the expression. Now here what I said, time is same, so if I taken d by dt as common, both sides will get cancelled out. We can get expression as q1 plus q2 plus q3 is equal to q4 plus q5. Means we can say here, see whatever the charges are entering to the node, same charges are leaving. Means we can say here there is no accumulation or wastage of charge. Hence we can say KCL will obey law of conservation of charge. Remember, KCL will obey law of conservation of charge. This is about Kirchhoff's current law. So we can say with other than current we can say the sum of charges entering the node is equal to sum of charges leaving the node at particular time. It's about Kirchhoff's current law. Next, Kirchhoff's voltage law. It's simply KVL. Now KVL is now there. See, KCL is we are going to applying there at a node or branch. Now here KVL will apply in a loop or a closed path, any closed path. Now if we come to definition of KVL, you can say in a lumped electric circuit, the algebraic sum of branch voltages in a loop at any one particular time t is 0. In lumped electric circuit, the algebraic sum of branch voltages in a loop at any one particular time t seconds is 0. To explain this, I'm going taking one loop there here with two sources and the two passive elements. So here sometimes we can say source also a passive elements. Why? Because of another source, so other source will takes the energy. Why? Because of high magnitude, so high magnitude person, energy will travels from him to low energy power person. That's why sometimes sources will work as a passive elements. Of course they will give, even though, but because of high energetic source, they will take the energy. Practically, if it's like any person is having more height, he will dominate the less height person. Means no doubt he is having more energy level compared to other person. Now in that loop, if I apply KVL, Kirchhoff's voltage law, I am going to apply in a loop. What I said, largely some branch voltage in a loop is 0. So for that, I assumed current flowing in clockwise direction some magnitude. Then how all elements are connected? We can say series connection. Why? Because there is no principal node or simple node. Simple node will exist how many? Between how many elements? Only two elements. If elements are existing between only two elements, then we can say those two elements are connected in series. We'll see in the next session about series parallel technique. Now, if current is flowing through any passive element, according to Ohm's law, voltage will exist. Now see here, whenever current is entering to the any passive terminal, then that element terminal will represent with the positive symbol, and current leaving will represent with the negative symbol. But source's polarity is same as usual. Source's polarity never changes. For the passive elements only, we define the polarities. Depends on current. Means if current is entering the terminal, we define with the positive terminal. Leaving, we define with the negative terminal. Remember, if any element current is flowing from positive terminal, current is leaving from positive terminal, we can say that element is giving or delivering energy to the other elements. Otherwise, current is entering into the negative terminal also, we can say that element is delivering energy to the other elements. If the element current if any element current is entering into the positive terminal, then we can say that element is taking or absorbing power from the other elements. Taking or absorbing. Now with this knowledge, if you apply KVL to the given circuit, see the given circuit, if you apply, we can get expression as minus V. Here I am going taking, if current is entering into negative terminal, I am going to representing with the negative magnitude as negative. So minus V1 plus I into R1 plus I into R2 minus V2 plus V3 is equal to 0. From this we can say from now branch voltage taking voltage equal to branch voltage giving voltage in a loop. We know the expression at a particular time we are going to apply. We know the expression for instantaneous voltage V is equal to dW by dQ. dW by dQ. Here our elements are connected series. So charge entering at any node is equal to charge leaving from Kirchhoff's current law. So with that we can write this. With that I can say here charge is same through each and every branch or node. Why? Because connected in series. So if we take in dq by d by dq common, we get expression as w1 plus w2 is equal to w3 plus w4 plus w5. Means here some elements are giving energy and some other elements are taking energy. Means is there any wastage of power? No wastage of power in case of KVL also. With that we can say KVL will obey law of conservation of energy. KVL will obey law of conservation of energy. See here all definitions I was given how to represent the polarities. It's about to Kirchhoff's voltage law. Next, applications of Kirchhoff's laws. While solving the networks, we use some applications, we use some methods, some techniques. These two techniques are called universal techniques. Those are applicable for all lumped circuits. Those are mesh analysis and nodal analysis. In mesh analysis, we apply KVL plus Ohm's law. In nodal analysis, we apply KCL plus Ohm's law. The main advantage of this method is, these two methods is to know each and every branch voltage, current and power for any lumped network. That too, very most one drawback will be there here. These two techniques will fails in some networks. In which networks are, if the network consists more than two or more than two sources, with those two sources are having different frequencies, then these two techniques will fail. You see here in the network, if all the sources are DC sources, maybe current sources or voltage sources, mesh analysis and nodal analysis are applicable. Why? Because for DC, pure DC frequency is 0. We discussed already. The frequency is nothing but what? Number of cycles per second. If you take DC supply characteristics, cycle you won't get at any time. That's why you can say number of cycles are 0. If number of cycles are 0 at any time is, then frequency is equal to 0. That's why frequency is 0 for DC networks. Hence, for DC network, mesh and nodal will apply for each and every problem. Now, how to apply mesh analysis? What are the instructions we have to follow? That was given here. For universal steps are there to solve any network or any problem by using mesh analysis. Those steps are: step 1, identify the number of meshes. Identify the number of meshes. What is a mesh here? Mesh means nothing but it's a loop which doesn't contains any other loops within it.